So we've talked about integrating Hadoop with SQL solutions, MySQL, RDBMSs, if you will, relational database management systems. And those are very handy for giving you the power of a rich analytical query language like SQL to answer business questions. But, they do take a little bit of time to execute. So if you're doing analytic work, relational databases are awesome, right? Putting your data in there makes a lot of sense. And even if you're running a small, like say an internal website or a very small scale website, something like MySQL can even vend that data to the outside world pretty well. But let's imagine you need to take things up to the next level. You're going to start to run into some limitations with SQL and relational database systems. Maybe you don't really need the ability to issue arbitrary queries across your entire data set. Maybe all you need is just the ability to very quickly answer a specific question like, what movie should I recommend for this customer, or what web pages has this customer looked at in the past? And if you need to do that at very large scale, very quickly, across a massive data set, something like MySQL might not cut it. If you're an Amazon or a Google, you might need something that can even handle tens of thousands of transactions per second without breaking a sweat. And that's where NoSQL comes in. So these are alternative database systems that give up a rich query language like SQL for the ability to very quickly and at great scale answer very simple questions like, what is the list of things associated with this other thing? What are the movie recommendations for this customer? What are the pages viewed by this customer? What did this customer order in the past? So for systems like that, you want something called a NoSQL, also known as non-relational databases, or not only SQL is a term that comes up sometimes too. And these systems are built to scale horizontally forever, and also built to be very fast and very resilient. So let's talk about some of the tools in your NoSQL tool chest coming up next. Up first, let's talk about HBase, the first tool in your NoSQL arsenal. This is probably the most relevant database technology to this course because HBase is actually built on top of HDFS. So it allows you to have a very fast, very scalable transactional system to query your data that's stored on a horizontally partitioned HDFS file system. So if you need to expose your massive data, your big data, if you will, that's sitting on your Hadoop cluster, HBase can be a great way to expose that data to a web service, to web applications, anything that needs to operate very quickly and at very high scale. Let's see how it works. Let's talk about NoSQL, or alternatives to relational database management systems. So sometimes you have a simpler use case where you just need to answer a very simple question at very high transaction rates on top of your massive data set. And sometimes an RDBMS, or relational database management system, isn't going to cut it. So one of the books I have about NoSQL databases has a subtitle that says Random Access to Planet-Sized Data. And I kind of like that way of thinking about this problem. Imagine that you're a Google or an Amazon of the world where you really do have massive amounts of data about a large percentage of the global population. We're talking truly big data here, right? So that has to live on some sort of distributed cluster like a Hadoop cluster. You're just not going to fit that into a single hard drive on a single database, right? You need something that's more horizontally scalable, where you can keep on adding capacity as your data continues to grow over time. And if you think about things like Amazon or Google, people are always buying new things, they're always searching for new things, new websites are always coming out, so this data is always just getting bigger and bigger and bigger over time. So, you need something that you can just keep on throwing more computers at the problem to solve it. And it's not just about random access to planet-sized data, it's also planet-sized access to that data. So they have, millions, maybe even like approaching billions of customers in some cases, and all those people are hitting their web servers trying to get access to this data. So imagine you're running a website like Amazon where you need to very quickly retrieve, the list of things people ordered or the things they looked at or what movies they should be recommended, or on Google what they searched for in the past. That all has to happen at extremely large scale. So, tens of thousands of people per second might be hitting your service to actually retrieve this information in real time. And again, a single Oracle database or MySQL database is not going to cut it when you're talking about that kind of transaction rates on that large of a data set. So what do you do? Well, let's talk about what you don't do first. So one solution is to just keep on going through extreme measures to make your relational database management system scale up. And back when I was at Amazon, this was before the days of NoSQL and Hadoop, and this is kind of what we had to do. And believe me, it was ugly. I mean, this is what leads you to getting paged at 2 a.m. in the morning every day. Now, there are ways to get a database, a relational database, to scale up to larger data sets and larger transaction rates. One of the first things you can do is denormalize your data. And that means that, take the example of, looking up, orders for a customer. You might have a separate table for the customer's name and address, and then another table that references that table that has the actual list of orders for that customer. Now, joining those tables together is a pretty expensive process. So if you need to increase the efficiency of your database, one thing you can do is pre-materialize views that contain data in exactly the way that your services need it. So if your website expects to get back a list of customer name and order IDs and order dates and item names all together as part of one query, one transaction, then you better have a table that has all that information all in one place ready to go. So it doesn't have to scan across the disk multiple times to answer that one question. Those disk seeks are what kill you. You'll also end up putting caching layers on top of your database. So one trick we did was build services that were just a giant cache on top of an Oracle database using something like memcached so that it would have a distributed in-memory caching layer sitting on top of the physical database. And hopefully, if your access patterns were the right ones, you could end up caching a lot of those information in memory and prevent a lot of traffic to the database from happening in the first place. Then you run into issues with the cache getting out of sync with the database, and that can get ugly too. You can also set up these master-slave setups with databases where you actually have multiple databases where one is required for handling writes and everyone else gets replicated to and handles reads. In some applications, that can help you for a little while, but maintaining that requires a DBA who really knows what they're doing. Sharding, same deal. If you need to add capacity beyond what you can store on a single database's hard drive, you can split your database up into range partitions where specific databases handle specific ranges of keys. But again, setting that up is a very manual process, and adding new shards can be a very painful thing to do. Materialized views, again, you can sort of materialize views of your data that have things in the format that your services expect. And you also end up doing things like removing stored procedures. So if you have a database where it's actually computing stuff as part of processing a query, that's also an expensive thing, and you often end up having to give that up as well, or moving that logic elsewhere. So you can see vending planet-sized data at planet scale is very challenging when you're dealing with something like MySQL or Oracle in a database system that's really meant more for analytic queries. And as you can see, your hair will in fact catch on fire, your servers will explode if you go down this path. And in reality, what will happen is you will not get any sleep because you'll keep getting paged at night because your service and your database melted down at a very inconvenient time for you. So, at this point, you should step back and ask yourself, do I really need a relational database? Do I need SQL? Maybe not. If you're building a website like Amazon or Google, you probably have very specific queries that website is asking for. In the case of Amazon, what pages have I looked at? What's the item information associated with this item? Things like that. And you don't really need a rich query language for answering that sort of a thing. All you need is an API that says, given this customer ID, give me back this list of information, or given this item identifier, give me back this information about this item. So more often than not, all you really need at runtime is a simple API that allows you to get information for a given key or put information into a given key. So these are, basically key value data stores at a high level. And if that's all you need, then you don't need a big fancy relational database. All you need is a more scalable system that can be very easily horizontally partitioned for given key ranges that just answers the question, give me this stuff for this key. Okay? And you can always do both too. For example, you can have a Hadoop cluster that you're running Hive on or Pig or Spark or what have you to actually answer the more complex questions that you have. But for the things that you're doing at very high scale, very high transaction rates, you can bolt on a NoSQL database to actually handle that part of the problem. So it's not a question of one or the other. It's about having the right tools in place for the right jobs. For example, let's make this real with a little simple architecture here. This isn't really representative of any specific NoSQL database technology, but the idea is this. Say your clients actually know how to route a request for a given key ID. So your client, this could be, for example, a web server that's generating a web page for a known customer ID. It might know where to go to actually get information for that customer. So if I have multiple shards on my database, they each handle some subset of my customer population, it can know where to go to get that information. And maybe you have some sort of backup system to make sure that if one of these databases goes down, it can fail over to the backup system and not have any interruption in service or any loss of data. In fact, you might even have more than one backup here. But the idea is that we keep it simple, right? If we're a given client ID, we can just hash that or something, pick a given instance of the database to ask the question, go look up this information for this key. It's a very simple thing to do, returns it back. Your web application can then format that, make it into a pretty web page, and give it back to your customers. So very efficient way of doing things. And if you do need to add more capacity, you just add on another shard and update the client to let it know how to actually find the right shard for a given customer ID. So this is a more scalable and a much more simple solution. And the key is on simple. When you're dealing with things at very high scale and high transaction rates, you want your solution to be as simple as possible. The more complexity there is, the more moving parts, the more likelihood there is that one of those parts will break at a very inconvenient time. So again, it's about using the right tool for the job. So if you're going to be doing big analytic queries, you have some business report to write, you want to figure out what are the demographics of my users, how are people responding to this experiment? Great, use Hive, Pig, Spark, whatever you want, Tableau, I don't care. That can sit on top of your data just as well as something like HBase or any other NoSQL solution that we're going to talk about can do. And, you don't always need a NoSQL solution. I mean, if you're just running some internal service, like an intranet sort of a thing, MySQL or something like that is perfectly appropriate. MySQL can actually scale up pretty far on its own. It's only when you get to these really large, really massive planet-wide applications where it's going to run into a lot of trouble. So if you know for a fact that your scale is going to be limited, maybe something like MySQL is totally fine, even for interactive online transactions. But if you do have the potential of, becoming the next big thing on the internet, it makes sense to think ahead and actually make the right architectural choices to have a non-relational database vending your data whenever possible, because that will be the simplest and most scalable solution available to you. Let's look at something a little bit more complicated here, and just kind of like imagining how these different systems might fit together. Let's imagine that, I don't know, we're trying to vend the last few pages that a given visitor looked at. Okay, so we might have a data source that's the actual web servers for a website like Amazon or something else. And that can be feeding data in real time to your Hadoop cluster through a technology, for example, Spark Streaming, Flume. There's a bunch of things that we'll talk about in that arena that can just listen to data being published from a huge fleet of servers. And then it can turn around and publish that as it comes in after transforming it to the exact views that you need for the front end into something like MongoDB or some other NoSQL solution. That's one of many that we'll talk about. And then your front end web servers, again, can come into the mix and say, hey, MongoDB, give me the list of the most recent web pages that were viewed for this customer ID. And it will have that handy and ready to go without going back through this path here, okay? And then through the internet, that can be vended out to the actual web browsers of your happy customers. Now, bear in mind, every one of these boxes can be an entire fleet of machines, an entire cluster of itself, right? So obviously, if you have millions of customers, there's millions of machines here. If you have a very large website, there will be, hundreds or even thousands of web servers constructing web pages for those customers. That might in turn be talking to a fleet of your NoSQL fleet that might have, tens to hundreds of instances in itself. Spark Streaming, your Hadoop cluster itself could be composed of tens to hundreds or even thousands of machines, and you could have hundreds of web servers publishing data into it, right? So the beauty of the entire Hadoop ecosystem is that we can think about applications in these big blocks, and the technologies within these blocks worry about the complexity of scaling it up for you, okay? So we're just kind of like assembling pieces here, but under the hood, every one of these boxes are doing something pretty awesome and managing an entire cluster of computers to solve a very specific job. So again, choose a database design that meets your usage patterns. When we're done with this section, we'll come back and look at some real-world examples and how you might actually influence your choice of database technology based on how you're going to be using the data in question.